Sorry, I'll have to sit down so I can write. Please don't get offended. And if you do, don't tell me. Okay. It's a very easy topic for the first day, so you don't quit the maths. No. This is how we start. Yeah, we build up from easy concept, and then we excel in those. Okay. Welcome to MATH11246. Again, we'll start with week 1 content. This document uses material from the set textbook Essentials and Example of Applied Mathematics, written by Professor William Wu of CQU. We'll start with acknowledgement of country. We respectfully acknowledge the traditional custodian of the lands on which we work and learn. We pay respect to First Nations people, the elders past, present, and emerging, for they hold the memories, the tradition, the culture, and hopes of Aboriginal and Torres Strait Islanders people. Aboriginal and Torres Strait Islanders people should be aware that this course may contain images, voices, and names of the deceased person. It doesn't, but we have to. Right, so some quick revision. Rules of precedence. Who knows what is rules of precedence? You know that? Kind of? What is that?
It's BODMAS.
BODMAS, yeah.
It's multiplication, division, subtraction.
Awesome.
Yep.
Yep. Who else knows what is rules of precedence? You know that?
Isn't that the PEMDAS in English or whatever it's called?
Sorry?
It's like parentheses, evaluation, and I don't know how there's multiplication, division, PEMDAS thingy.
Yep. Anyone else?
Was it BITMAS and BODMAS?
Yes. Until my study, I was a fan of BODMAS, but when I start teaching, I'm a fan of BIDMAS. Right? BIDMAS, BODMAS, same thing. Yeah, good. So, BIDMAS, what is it? The bracket, right? B for bracket, right? Anything within the bracket must be as a priority, right? Let's say you need to watch a Netflix movie that you think, if I don't watch it, it's like leaving Netflix in 2 days or leaving Prime in 2 days or something like that. And you need to catch a flight. What's your priority? Will you sit down at your home and watch a Netflix series or show or movie, or will you catch up a flight? So it's all about priority, right? So we'll start with the bracket. It's our first priority. Okay. And then we'll go with the innermost bracket if there are more than one brackets. Okay? Right. Then we got I is for the indices, right? Then we got multiplication and division, again from left to right. And then finally, we got addition and subtraction, right? Which occurs at the end, again from left to right. Right. So to start with, maybe questions? Please do it with me, right? So who will tell me this? I mean, you can do it on paper, in your brain, however you like. 17, yeah. So we start the BIDMAS thing, right? So we'll go for 7 times 2 first because multiplication has a higher priority than addition, right? So that's like 14 plus 3. Okay. Right, the next one. Right, what do you think of this? 4? Yep. Is anyone else got 4 as well? Sorry, I'm not observing the chat. Like I said, I want more interaction. So if you wanted to comment or have your input, please unmute and say it. Yeah. Okay. So with this one, we go for, I'll write it here. It is for BIDMAS. Yeah. Bracket, indices, division, multiplication, and addition, subtraction. So we'll start with the bracket. -3 plus 5, which is 2 times 2 And obviously 2 times 2 is 4. Next one. 3. Yeah, good. So we'll go with the division first, even though there is a negative at the front, but subtraction addition comes last priority. So no bracket, but you can consider like a bracket to set a priority. That's 2. 5 minus 2 is 3. Good stuff. Okay. Anyone else from online?
6.
Good. Thank you. Right. So we'll start with the bracket first. So that is 8 minus 4 divided by 2. Don't be prompted for going 8 minus 4. Yeah. Follow the BIDMA stuff. So 4 over 2, that goes first. And then 8 minus 2, which is considered 6. Any question along this? Feel free to raise it to me. This was, I think, grade 6, grade 5, long ago. Yeah. So it's not difficult, but we might have forgotten it, right? Like we weren't sure about board mass, bid mass, you know, and sometimes we tempted to go for various order, but the rule, yeah, bid mass, board mass. Okay. What is algebra? Mm-hmm. Yep. Thank you. Same. Yes. Same. Anyone online? What is algebra? That's fine. Algebra is a math where you take symbols, you know, to represent unknown quantity, right? The temperature outside, we normally represent it by T. T stands for temperature, which keeps varying throughout the day, right? Symbols, letters, numbers, plus, minus, all that kind of thing. In some higher maths, you will find mathematical operation like star, which is a binary operation even in IT, right? That binary operation can be manipulated however you want. So A star B could be A plus B whole square. A star B could be A power B, you know, don't worry. But just telling you, right, that is also an part of algebra, right? We don't go that far. We just go to this 4 basic operation, and exponential and all that, you know, but like addition, subtraction, division, and multiplication. Right. So operators are 4. We know the variables which vary, as the name says. That's why we keep them the letters, right? Okay. Traditionally, we keep A, B, C as constant and X, Y, Z as the variable, right? This is a notion, right? Okay. Who knows the difference between expression and equation?
It's an equation just like one, like, you know, something like an expression links like multiple equations, something.
Could be, partially, yes. Yes. Can you say? Not really? Okay.
Is an expression is the equation can't explain it there. So the expression would be the answer of the equation, perhaps?
No.
Okay.
Really, sorry. No. Okay.
Doesn't an equation have to have an equal sign, but an expression doesn't? You can have an expression without having that it equals something, because it might not equal anything. It could just be an expression. It's
Awesome.
just expressing something.
Awesome. Perfectly said. Thank you, Ben. Expression, simply X is an expression. But the moment say X is equal to 2, that becomes an equation. Now, that's what I said, a very simple equation, simple expression. I could also say 2x plus 3y plus 5, right? 2x plus 3y plus 5. I mean, there are a lot of examples coming up. I'm just trying to input something in your brain before it comes up. So 2x plus 3y plus 5 is an expression connecting x and y, mathematical operators, and the constant. But the moment I say 2x plus 3y plus 5 is equal to 0, becomes an equation. Equation should have an equal to sign, right? So an expression with an equal sign, doesn't matter what is right hand side, becomes an equation, right? So expression is a collection of variable and numbers linked by one or more mathematical operation, right? So something like this is all constant, all numbers. That is an expression. Expression containing t, a, and some constant, t and a together, they are all expression. But the moment I will assign them is equal to 0, is equal to 5, something equal to, it will become the equation. Equation then can be linear equation, one variable equation, quadratic, multiple variable, a couple of, a system of linear equation can be really built up, right? Okay. A term is a component in an expression that is added to other part of the expression, right? So what are the terms here? 8, 3 times 2, 5, negative 5, 5t, 7a, they are all the terms. Right? Then we got a constant and a variable term. 8 is a constant, while 5t here is a variable term. 7a is a variable term. Right? Variable term has one or more variable in the term, while constant is only a number term. Okay, so are we all clear with the term, expression, constant, and variable? Yes. Just FYI, I mean, you won't get a question like, oh, list all the term. Otherwise, doesn't look like a uni exam or uni assessment. Looks like if someone look at that assessment, they will say, oh, I need to contact the term. What is it doing? Right. I think it's the same slide. So, yeah. Like terms. They are the terms with the same combination of variable. Like when I explain this to a young kid, like very young kid, how would you explain someone like terms or unlike terms? How would you explain it to someone? Mm-hmm. Yep, true. Yep. Yeah. No, that's perfect. But even to take a step further, see, I'm always aiming at you are explaining someone, right? True. So if I ask you a question, what is 5 apple plus 3 banana? You'll say nothing. You can't add them. But if I ask you 5 apples and 3 apples combined together, you will say 8 apples. So what you say, B for banana. 14 banana and 7 banana, kept them in a basket, some raw, some right, that's 21 bananas altogether. So like term, which can be added or subtracted or manipulated, right? And unlike term, obviously, which can't be simplified that easily, right? Okay, can't be combined rather than simplified, yeah? Right, so 6 and 14a are like terms. 7xy and 2yx, are they like or not? Yeah, because xy and yx are the same thing, yeah? Is x over y and y over x are the same thing?
Yes, because you can switch up multiplication anytime. That doesn't matter the order.
True. Okay, but my question was, I'm not sure whether it's a bad name or thing. I'll repeat it. X over y and y over x are the same thing.
Oh, no, that's not. No, that's not.
Yeah. Sorry?
No, that's not the same. X to
Even
the
if
y and y to the x.
They are not same. Even if you consider negative power on both or just one, then they will swap. On one, then they'll be same. Yeah. But in general, I mean, we know that. What is that property called? I'm very keen to go deeper into it. What is the name of that property? Where you say 2 plus 3 and 3 plus 2 is the same. Where you say 2 times 3 and 3 times 2 are the same. What is the name of?
That's commutative.
Commutative. We are almost there. Who was it? Okay.
Compounding?
Yes. Commutative.
Yep.
Commutative property. Right? Where you say 2 plus 3 and 3 plus 2 are same. 2 times 3 and 3 times 2 are same. It's called commutative, right? But 2 over 3 or 2 divided by 3 and 3 over 2, they are not the same. Yeah. Good. I mean, it's again basic refresher. Yeah. Why it was important? Because in the second example up here, I said that 7xy and 2yx are like term, which is true because xy is the same as yx. MNP and 15 MNP or 15 NMP, 15 PMN, they are all like terms. Terms, they have no identical variable, are called the unlike term. 7 apple and 7 banana are unlike. MN and M, 3xyz and 4x are unlike terms. Don't add them. And you know what? I can't disclose or I can't show you the evidence for the privacy reason, but my memory says 40% of the student still get them wrong in uni. I'm talking MATH11246. Looks very basic. I know that. Why is it going through like that? If a student allow me, I'm happy to demonstrate that live paper submission record where you mix them up, like literally mix them up. Yeah. Okay. So if you find this easy, you are clear. That's what we want. But please observe it. Yeah. There is a reason they are a part of this slide. Yeah. Right. The factor. Factor is an expression where 2 or more factors are multiplied. Sorry. A product is an expression where 2 or more factors are multiplied. So what are the factors of 6, 2, and 3? What are the factors of 3a, 3 and 8? Right? Who would tell me what are the factors of 8? Yes. Anyone? Factors of 8?
2 times 4.
Very good. Anyone else?
1 and 8.
Very good. I was expecting someone to say that. Good job, Ben. Sorry, I'll keep saying the name. I hope you don't mind it. Yeah, it's been recorded, but I have to tell you by a name rather than saying, hey, student number 1 said the right answer when it doesn't help. Yeah. So I keep saying the name. Yeah. Hope you don't mind it. Right. So when we come across the factor, I would expect you to say 1, 2, 4, and 8 are the factors of 8. Yeah, because this is how we bifurcate between a prime and a composite number. We are not going there, but a prime number. What are the factors of prime number? 1 in itself. Awesome. 1 in itself. That's where the IT comes, right? You would have run some programs to identify prime numbers. Yeah. Right. So yes, the 1 in itself. Only factors of a prime number are 1 and the number itself. If there is more than 2 factors of a particular number, then the number is classified as not prime, or to be precise, is composite. Okay. What is 1? Is it a prime or composite?
It's not a prime number.
Good job. Who was it? Austin or Ben?
Gabo.
Okay. Gabo, sorry. Good job. 1 is neither. Because the prime definition says only 2 factor. Composite says more than 2 factor. 1, only 1 factor itself. Or 1, what you call it, right? So neither of them. Good job, Gabo. Do I say Gabor or Gabor?
Gabor.
Gabor. Okay, that's it. Thank you. Right. So far, so good. Who knows these fancy symbols?
I looked at it in grade 11 and 12. My specialist maths teacher showed it to us.
Very good. And do you remember them?
I remember some of them, but not all of them.
Okay. Tell me what you remember. I got some answers from the class here, which is true as well. So tell me what you know. Okay, let's start with N. What is N?
N is like all the positive numbers, right? Or like
Yes, there is a name for it. That is called the natural number.
natural.
N is a set of all. I'll go over each of them again, so don't worry. Yeah. What is Z?
Z is like all of the integers, so anything between infinity and negative infinity.
But without fraction and decimal. Yeah.
Yeah.
True. What is Q?
Q is anything like any I can't remember Q.
Okay, that's fine. You said rational, right? Yep, rational number set. Very good.
Yeah.
What is R?
R is all of the real numbers, correct? It's
Yes, R
anything
is all the
that's
real numbers. True.
not
And what
imaginary.
is
Root of 2.
root of -2? Root of -2. Yeah. Yeah, you're very close. Root of 2 is irrational, which is a part of R. Yeah. Good. Very true. C for the complex number. Okay, sorry, we dropped R. R is the real number, R for real, which is rational and irrational. Don't worry, I'll explain each of them individually and write them on the screen as well. The C is the complex number, which is real and non-real, right? So if you could recall the discriminant method or root of a quadratic expression, where x square is equal to -4, we say no real roots. X square is equal to -4, we say no real root because the roots are not real. They are imaginary, which is called the complex number. Right. So N is contained in Z. Z is a part of Q. Q is a part of R. R is a part of C. N is a set of natural numbers starting from 1, 2, 3, 4, 5, as long as you can go on. Right? Number of stars. There is no fraction star. Yeah? Is being born or is being died? Is born, is +1, died, -1. That's it. So the total count will be some numbers, which you obviously can't count it. I mean, you can, but we don't know the output, right? Z, set of all integers, all the negative, the 0, and all the positive number is called the set of integers. Q, set of all rational number of the form P by Q, where P is an integer, Q is a natural number, right? I will write something about Q here. It is called either recurring or terminating. So when you express number, it's a rational number, right? Again, recurring number. An example of a recurring decimal number? Is a rational. Yep. Something which is recurring, happening, repeating, in other words, decimal number, 1/3. What is 1/3 in decimal? 0.333333. When will it stop? When you're tired. When we are tired, we said, that's it. I'm not going further, right? Or your computer doesn't allow, or your calculator is only 8-digit, but it will keep on going. So 1/3, 1/7, 22/7, all that kind of number, right? They are all rational number of the form P over Q, and this particular set of example is for the recurring number. What is terminating decimal number? For example, a quarter, very good. How about half? Yep. 3/4, 1/8, 1/10, or 11/12, for example. They are all terminating number. It will stop, right, after a certain number of decimal. So any number of this form is considered or classified as a rational number. Okay? Then we go to R, set of a real number, which comprises of rational and irrational. Rational number, that is our whole Q. Yeah. An irrational number, which is outside of Q, such as √2, pi, negative e square, 1/√3, right? Now, who will comment on this? As a kid or a high school kid, we used to take pi is equal to 22 and 7. Who remembers that? Vaguely? Yeah? Right. I remember that our teacher used to tell us that take pi is equal to 22 and 7, especially when your radius was 7 or 14 or something like that. Yeah? But the math says that 22 and 7 is a rational number, right? but pi is an irrational number. So it's like equaling a negative and a positive. How can you say -2 is 2? No. So how can you say pi is equal to 22/7? Who would comment on this?
Because it's a number which is not repeating. It's repeating and sorry, it's not repeating, non-repeating, and non-terminating. So just keeps going on, and it's not repeating.
So that's pi, yeah?
Yeah, that's what makes
Okay.
it rational.
No, pi is purely rational. That's for sure.
Oh, it's rational. Pi is rational.
Irrational.
Oh yes,
Irrational.
yes, that's right. Yep.
Pi is irrational.
Yep.
Right? So any number which is irrational will not have a recurring or a terminating decimal expansion. You take out your calculator and obtain √2, which is 1.4143 or something. I don't remember top of my head, but 1.41 something. None of the decimal, of course, decimal are 0 to 9, but they don't repeat in a pattern. So if I ask you the 10th decimal point, 10th place, right? You can't predict unless you have a calculator in front of you. Oh, this is 1, 2, 3, that's 15, right? Same thing with pi. You can't tell the exact digit, the 10th or 15th or something, unless you memorize it or see it on a screen. So they are purely irrational number, right? Now the question is, if they are different, like different set altogether, when you see set theory, one is like a good boy, a rational number, that's about 22/7, and kind of a bad boy. I mean, good and bad, not a correct reference, but just telling you they're different, right? How can they both be compared?
It's because 22/7 starts off as 3.14 and then changes from what pi is, but we often take pi as 3.14 for simplicity's sake, even though we know it is much larger and much weirder than that.
Very good, Ben. I wish I can meet you personally, but 10 on 10 for that one. Great job. So take out your calculator. Take out your calculator or even, that keypad, whatever you have, or the laptop. Tell me the value of 22/7. And from my memory, I would say 3.142856, 142856, 142856 or 7, something like that. 22 divided by 7?
3.142857, correct. You're correct, sir.
Yeah, right. And then it keeps on repeating, right?
Yes.
142857, 142857, 142857, right? So you can guess that the 19th decimal, 19th digit will be 1. 20th will be 1, 4. So 4. Yeah? 142857, 142857. That's a characteristic of a rational number. Repeating, recurring, or repeating. Okay? Now, on a second tab or a second part, or just keep this in a memory, calculate the value of pi, which from my memory is 3.141519. Then I don't know. Yes. Right? So are they same? No. But as a kid, as I started my reference, you don't need to go beyond 2 decimal. Even in high school, many instances will go with 2, hardly, rarely 3 or 4 digits. So 3.14 is the same value for both pi and 22/7. And that's why, in order to simplify the calculation, my teacher used to tell that whenever the radius is like 7 or 14, multiple of 7, take pi as 22/7, otherwise 3.14. Because if you tell a kid that, oh, go for the pi value of 10 decimal, they say, I don't want to do math. That's it. Right? Okay, but they are purely 2 separate entity, 2 separate number. And FYI, more than 1 million decimals of pi is being discovered. Yeah, more than 1 million. That's very old data. Sorry?
I just looked at it now. Isn't it? It says here that the computer storage company has calculated the irrational pi to 105 trillion digits.
Could be, because 1 million is a very old number. And you might say, why do we need so intentionally? Like, there are so many greater phenomena using accuracy of pi. Okay? Right, okay. Any question on N? Oh, I have one more, sorry. The C. Okay, so are we all clear of NZQR? Okay, there's one more, and then we'll take a short break. C is a set of a complex number, A plus IB form, where A and B are R, so they are real number, and I is equal to square root of -1, or I square is equal to -1. Okay, this is kind of FYI, don't worry about it now. When you go in year 3, Math 13217, linear algebra, not Algeria, and complex number and vectors, I will take you a lot deeper into complex number set. But for now, FYI. Okay, whenever you see a negative inside the root, that number is classified as the complex number set. Okay, any questions so far? I'll pause the recording.
So set of complex numbers doesn't really need to be studied at this stage?
Not at this stage, you're right. Not at this stage. Because I have to reference all the NZQRs, I can't really miss out C, you know, before someone asks me, hey, what happens after that? But this is all the thing, you know, the baby, the father, the grandfather, and the godfather, everyone is here, NZQRC, yeah? That's everything, the number system, yeah? Rational number, a bit more about rational number. Which I already covered, so I'll quickly review it. So rational number that can be written as the ratio of two integer, or as you call it, a fraction. You know, all integers can be returned as a rational number because the denominator can be set as 1. Yeah, and therefore every integer could be called a fraction as well. Yeah, a rational number, and that's why every natural number is an integer. Every integer is a rational, every rational is a real, every real is a complex, right? That's a whole chain. Right. Not all the decimal are rational, like root 2, 1.41, and unrepeated or unpredictable pattern doesn't terminate, right? Terminating decimal and recurring decimal are the only rational number where then can be written as a fraction. So, who are the rational number? They are the fractions, they are the mixed numbers. Who knows what is a mixed number? Yes, that's right. 2.5, right? So two integer and a half, yeah, mixed number. Integer, terminating decimal, and recurring decimal. They are all the rational numbers. Right? Irrational numbers. They are the numbers that are not rational. That is, they cannot be written as the fractions. Right? We already seen some example. The real number, I already explained, you know, can be classified as positive or negative or zero. This is kind of fun because we kind of covered everything. Yeah. If there is no positive return, it's by default considered as a positive. That's a number line with 0 up here. To the right-hand side of 0, we have all the positive. Left-hand side is all the negative here. And then we got some fraction, the decimal, everything that sits in between. Okay.
Sorry, can you just explain the real number line, please? Because I looked at the textbook, I just didn't understand what that was, what that had anything to do with real numbers.
Okay, so real number line is where you plot the real number. So for example, it will give you a, I mean, this is again a basic thing. Maybe you say, oh, okay, that doesn't seem important to me. But for example, if you have to justify 2 and 5, which one is a bigger, which one is a smaller, then you put them on a number line. 2 is here, 5 is somewhere here. The more you are on the right-hand side, that number is bigger. So obviously 5 is bigger than 2, or 2 is smaller than 5. If you move left on a number line, you are decreasing the value, right? The more on the right-hand side, you are increasing the value. And it could be like when you're not sure, 10 over 3, and say, for example, 14 over 5. Looks like, oh, one is 10, other is 14, right? But unless you put them on a number line or have the actual decimal representation, you can't really comment. This buddy is 3.3 and the other one is 2.8, right? So even though 10 looks smaller, 14 looks bigger, when you convert them into decimal or put them on a number line, 10 over 3 is bigger than 14 over 5. Yeah? Make sense?
Yes. Does that imply that you can't input irrational numbers into the number line?
You can, absolutely. Any real number can be input here, but not the non-real number. So irrational number, say for example, pi is 3.1415 blah, 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 19. That is somewhere here.
Okay, gotcha. Okay.
Yeah. And root 2 is 1.41. That's here. Yeah, you can, absolutely.
Thank you.
Non-real number are input not on a number line, but on a plane, the XY plane, if you recall from your earlier standard memory. Yes. The real axis is 1, the imaginary is 3. So this is 1 plus I3 or A plus IB or 1 comma 3. That's a complex number, a part of C. Yeah. Don't worry. Like I said, complex number is not a part of this unit. We will take a look when it comes in year 3. Yeah. Not now. Okay. Yes. Any more questions? Please keep shooting any questions. I love to explain it. That means you understood a bit. There is something that's bothering you, and it's better to clarify. Sorry, don't judge me because I'm got a second screen here where I'm looking at. I got a tiny participant window, tiny chat window, so I'm looking at that. Yeah. Cool. Right. Okay. So let's look at the arithmetic operation. So there, this is the commutative rule. Remember, I mentioned just before a while. It's good to familiarize yourself with the name as well than just the property because you will use it in future, right? To explain it to someone else. Okay. Sorry, again, it's more for the education course, yeah? If you are to be a teacher, you will explain someone else, right? Inverse rule of the addition, commutative rule of multiplication, and inverse rule for multiplication. Okay, right. Simple stuff. A plus B is B plus A. We don't need any explanation for that, right? 2 plus 3 is the same as 3 plus 2. If B is minus A, then A plus minus A minus A plus A is 0. That is called inverse rule of addition, which we also call the opposite number. 2 and minus 2, when added together, the outcome or the addition is 0, right? Then we got the commutative rule of multiplication. 2 times 3 is the same as 3 times 2. Yeah. 500 times 6 is the same as 6 times 500. Is the same as 60 times 50. Is the same as 600 times 5. Yeah, but this is very obvious. Then you are just writing 1 0 with 6 and yeah, 2 0 with 6. They are everything is same. An inverse rule of multiplication, 2 and 1 over 2. 3 and 1 over 3. They are all the inverse things. Yeah. Okay. Then let's get a bit more fancy. Associative rule of addition and associative rule of multiplication. Association. Here is B and C are associated. Here A and B are associated. B and C, A and B. Okay, for multiplication and for addition. So what we are saying here, 2 plus 3 plus 5 is the same as 2 plus 3 and 5. This is 2 plus 8, which is 10. 5 plus 5, that's also 10. Similarly, 2 times 3 times 5 is the same as 2 times 3 times 5. They both will be the same. It doesn't hold true for subtraction or division. It's only addition and multiplication. Okay. That's good. This is my favorite distributive rule. A times B plus C is AB plus AC is also BA plus CA. Who will explain me this part? What have I done here? What is the name?
It's only plus AC because the A comes from the B and C, so it just goes very
True. Yep, true, absolutely. With this one, AB plus AC and BA plus CA, what have I done from this step to here?
just reverse.
What is the name? What is the name? No? I just said the name. What is the name?
The commutative rule of
Very good.
multiplication.
Very good. Commutative rule. Good. AB is the same as BA. Commutative rule. We just saw that up here. Yeah, AB is BA. And similarly, AC is CA. Commutative rule. And then this one is called reverse distribution. Like A is common, then you write B plus C or C plus B. Yeah, it's called reverse distribution, right? So, quick explanation of that. 2 times 3 plus 5, which is 2 times 8 or 16. If I had to expand it, then 2 times 3 and 2 times 5. Say, if you don't follow the BIDMAS rule, we'll never verify if it is true or false. Yeah, multiplication comes first. Yeah, that's 16 as well. Easy peasy? Yeah. Please get the distribution rule right, especially the reverse part. So when I say reverse part, if there is, say for example, 5x plus 7xy by distribution, you will say x and 5 plus 7y. It's also called factorizing or reverse distributing rule. Yeah. Whenever you see something common, take it out and keep it. Yeah, 5 plus 7y. Right, Austin? Okay. Not a commutative rule, but a different way of writing. A over B is same as A times 1 over B or 1 over B times A. Right? So for example, 2 over 5 is the same as 2 times 1 over 5 or 1 over 5 times. However you write it, it's all the same thing. Similarly here, you got two numbers up the front in the top. A, B over C is same as A times B over C. It's the same as A over C times B. Okay? Very much the same thing. Yeah. Some advanced distributing rule. Please take some moments to observe it, to look at that. And tell me if you find something abnormal. Not that you should, but tell me if you do. Yeah. Yes, that is a non-equal sign. Yes, now let me explain. I mean, it's simple, but still. Wow. So what we are saying, A plus B over C, like we have just studied, you can keep 1 over C outside, or you can write this by separating the numerator. So it's A over C and B over C. And obviously, if you want, since you've got two numbers in addition, yeah, you can swap them and write it like this. Okay? The second part, A plus B over C plus D. You can split the numerator but don't split the denominator. Don't do like A. Yeah, this is the biggest blunder that many students still do. Trust me, I've seen assessment and student doing it this way. Only the numerator is allowed to be splitted, not the other one. Okay, not the other one. Now, when you say A minus B, you can also write A plus minus B, or when you see plus and minus, when they are multiplied, they are treated simply as a minus. Yeah. And when there is 2 minus, minus times minus is plus. Yeah. I believe they are easy to understand. Yeah. So 2 minus minus 3 will be treated as 2 plus 3 and will be treated as 5. Okay. Please take A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. And please spend some time in verifying this 1, 2, 3, 4. First, second, third, and fourth. Please do it. Yeah. Input the values. A is 1, B is 2, C is 3, and D is 4. Yeah. And verify. Right. Quickly substituting all the values. The first one. 1 times 2 plus 3. So negative 1 times 5, that's negative 5. Yeah, the right hand side. Negative 1 times 2, negative 1 times 3, negative 2, negative 3 is negative 5. That's the first one here. So that's verified. They will be verified. If it is not, there is some error you would have done, right? Minus 1 over 2 or 1 over minus 2 is the same as minus r. Okay. But if you have minus 1 over minus 2, obviously the minus goes, and that is 1 over 2. Yeah, that's verified as well. 1 minus 2 over 3. If you separate this 1/3 minus 2/3, that's negative 1/3. And this is what this gives you. 1 minus 2 is negative 1 over 3. So that's verified as well. And the last bit, 1 minus 2, 3 plus 4. 1 minus 2, 3 plus 4. 1 minus 2 is minus 1 over 7. And therefore 1 over 7. If I plug in the last part, negative 1 plus 2 over 3 plus 4. That's 2 minus 1. That's still 1 on 7. And they have to be verified. Yeah. Good.
What about the movie?
Sorry?
Third. Oh, I didn't see the minus sign in front of the middle of each one.
Oh, here? You mean? Yeah. It's
Yeah.
there as well. Yeah. Yeah. Okay. Cool. Any question on those? Looks no. Good. Now, arithmetic operation with fractions. So you can separate the addition or subtraction as long as you carry the sign. Right? Please observe this plus minus. It could be plus, could be minus, right? As long as you carry over the sign, they can be verified. So 1 over 4 plus or minus 2 over 4 plus or minus 3 over 4. Whatever you choose, that will be verified. You keep them together, keep them separated. They're still fine. Now, this looks horrible when you look at like this, but I wouldn't explain that. Let me take an example. 1 over 2 plus 3 over 4. How would you simplify this?
5/4. 5
Something like
over
that.
4.
Yep. What is the process for? Okay. No, that's right. Yeah. Sorry. I think yes, Ben.
You find lowest common denominator,
Very true.
and because then they will be the same denominator, and so you can add or subtract them however you want.
I think someone else was saying something as well. Was it you only, Ben?
That was 5 over 4. Or not over.
5
Like the
over
denominator
4.
is gonna be
Very
4.
good.
You can add them together, then it's 5.
True. Full stop.
The same
Thank
as
you.
Ben.
Yep. Good. Right. So there are two terminology which I would like to introduce you. I mean, not necessarily that you have to remember me, but it's good to make yourself familiar. Right? One of them is called HCF. Good for you. HCF, highest common factor. I mean, FYI for you. Yeah. Highest common factor. And the other is LCM, least common multiple. Right? Least common multiple. What is that? So with the least common multiple, you make the denominator same, right? So we don't cross multiply and make it 8. We don't do that. Yeah. 2 is a factor of 4. So we go for multiple, like the way it works. I mean, this is very simple, but let me tell you something else here. Say, for example, 1 over 4 and 3 over 8, right? Another example. So 4 is a part of it, but what we do, the multiple of 4. How about 4 and 6? Then I make 5. Okay, 1 over 4 and 5 over 6. Okay, multiple of 4. The name is LCM, least common multiple. So let's start with the multiple. The multiple of 4. That is 4, 8, 12, 16, 20, and so on. Yeah, let me write 24 as well. Multiple of 6, that is 6, 12, 18, 24, and so on. So we talked about the multiple. Now we talk about C, which is common multiple. That's 12 and 24. 12 and 24. Okay. Now we talk about the lowest or the least common multiple. 12 and 24. Which one is the least? 12 is the least. So the LCM, right, or the common denominator of this will be 12. Okay. How do you make them 12? So this was 1 over 4. I would times it by 3, but I cannot do any operation only on numerator. I have to do it on denominator as well, right? So over here, 5 over 6 times by 2 times by 2. and that will give me 3 over 12 plus 10 over 12 and ultimately 13 over 12. Some smart fellow could also write one integer 1 over 12, which we call the mixed numbers, right? So that's a very good information, LCM. Right, up here, since 2 is a part of 4, the process is not simple. I'll multiply them by 2. So 1 over 2 is 2 over 4 plus 3 over 4. And like Gabo said, is 5 over 4. Okay. If it was a subtraction, you do the same thing. Now, this is what is been explained here. You multiply with B and B, multiply and divide. You multiply and divide with B and B. So this denominator becomes BD. This becomes BD. The top becomes AD. The top becomes BC. Since there is the same denominator, you can add and subtract and write AD plus or minus BC over BD. Yeah. Any question on that? Similar stuff. But here, there is no factor, so that's treated as 1. Easier, even easier. So what you do, again, let me pick up an example, 3 over 5. So what I do, 2 times 5 over 5. For simplicity, we write 2 over 1 plus 3 over 5. Yeah, so multiply and divide by 5. Why 5? Because 5 is the denominator here. Yeah, okay. So that is 10 over 5 plus 3 over 5. That is 13 over 5. And that's the answer. Plus or minus doesn't matter. Okay. You must flip it. When dividing a fraction numerator by another denominator like this, you must flip it, please, to convert division into multiplication, right? So that's similar to A over B divided by C over D, right? So what you do, A over B times B over C, that is AD over BC. Okay? That's what is done here. So you convert division into multiplication by flipping the next number. So for example, 3 over 4 divided by 5 over 8. That will be 3 over 4 times 8 over 5. So please observe, we are doing 2 change here. The division is converted into multiplication, and 5 over 8 is returned as 8 over 5 after flipping it. Okay. That is 3 times 8 over 4 times 5. Now, many smart people will multiply the numbers and then simplify, which I won't advise. I would say smaller the number if you can. 4 and 8 on 2. Yeah, that will be 6 over 5. What you could have done is 24 over 20 and then realize that 4 is common and cancel it. Or cancel before you multiply. I would prefer to keep the number smaller, but either way, it's 6 over 5. Yeah. Right, we are almost there. A divided by B over C. So that is treated as A over 1 divided B over C. Right? Again, the flipping rule stays the same, C over B, and that is AC over C. Example, 3 divided by 4 over 9, for example. Yeah, that is 3 over 1 times 9 over 4. Division converted to multiplication, the number 4 over 9 has been flipped into 9 over 4. And that is 27 over 4.
Can you
That's ridiculous.
likewise? Sorry, can you likewise flip over the other one if you want to convert it to division?
So you mean going from this to here?
Yes.
Yes, you can. I mean, you won't need it. The purpose of converting is to simplify, because in order to perform this simplification, it's kind of tricky. Yeah. And that's why we convert the division into multiplication. So you will have a beautiful number like this, or something like this. But if from this step, right, if you go back, what will you achieve? I mean, you
Yeah.
can, but what will you achieve?
Okay.
Yeah, makes sense. You can, absolutely you can. In order to answer your question, can you? Yes, you can. But you won't achieve anything except it says that, you did something. But aim is to achieve a simplification, a simplified fraction. And that's why we convert division into multiplication and perform the operation. Yeah. Cool. Any other questions? No? Okay. Then it's a Kahoot time. Okay. Right. Now, pardon my memory. I have kind of forgotten what I have done with Kahoot. So, what I will do, if this thing, I will pause the recording for a minute. Please go to Kahoot. It should say 282237. How many plus I have? 5 online and 2 here. I like to read it. I need 2 more. I only have 1 of these. Huh? Yes, I will share the screen. Yes. Sure. Yes, I'll have to bring it to the. Oh, that makes sense. Okay. I didn't realize what. Yeah. After I'm just closing some of the resources that I don't need. It says with a low resolution and everything. Okay. So 1, 2, 3, how many was that? 7. Is everyone ready? Right. And let's begin. There's only 4 questions, I think, to start with. Next week you'll have more, yeah? Which of the following is the biggest set among the 4 given? Good. So still 3 students got it wrong. That's surprising. Yeah. Obviously, when you see irrational, that's the biggest one. This is all positive. That's the smallest. Negative, that's Z. Other rational, that's Q. And only this value, right? Other irrational. Okay.
but for some reason I thought I actually meet. I don't
Just observe it. Yeah. So irrational is the biggest one, because when you say irrational, they can be treated as rational as well. Yeah. Anyway, because that has one as well. See, so it kind of covers everything, negative and all. Anyway, we got three more. Yeah. Okay. So who's sorry? Who is Soniva?
That's me.
Ah, Geber. I thought so. Good. Nice name. Good. Almost, Ben. It's a couple of microseconds. Yeah. And that's why the value of pi is couple of trillion decimals. Yeah. Or micro nanosecond is important. Anyway, we'll keep going. Next one. Which of the following is not a real number? Only two. Non-real. Can a square of a number be ever negative? No. X squared is negative 16.
You're kidding.
Can I ask something? Isn't it
Please.
like you have? Isn't it there a case when you can see a root and the negative number?
Sorry, say it again.
Can a negative number be put under a root sign?
You can, but that becomes non-real, a complex number, not a real number.
Oh, okay.
Yeah.
I'm worried about the
Because see, x squared is equal to 16. Yeah. Option A, first option. X squared is 16, which gives plus or minus 4. Both of them are integers. So an integer or a rational or a real. So first one, that red stuff is not the answer. No one ticked that. Good. The blue, x plus 5 is 0.5. So x is equal to minus 0.4.5. Yeah, that's fine. See, getting it right should be the first priority. Then getting it faster is the second priority. If you get it wrong, you got 0. Yeah. So obviously get it right is a priority. And then you think of how can I beat the time? Okay? The third one, x over 5 is equal to root 5. Root 5 is a real number. If you times it by 5, becomes a real number. Yeah. So even if you don't know square root of negative 16 or plus or minus 4i and all that thing, don't worry about it. Just say that's the only thing which is not real. Cool. Okay. Next one. Whoa. So that means our friend Gabor got it wrong. Yes. Good, Ben.
Indeed.
Okay. Next one. Got two more. Yes. Very easy. Now, up here, time matters. Yeah. So the question is easy. Time matters. Let's see. Bands, 3 stick in a row. Good. Right. And the last one. Give your best shot. Only 3 people got it right. You're one of them. Good. Huh? Rule out the one that's not correct. So it says not true. That means rule out the one that's true. Obviously, the first one is true. Commutative law for addition. Good job. The second one is true. The orange one, B minus C and C minus B. Don't worry about C. Okay, I'll tell you one thing here. There are two approaches in solving a problem. One is a traditional approach, step by step, all details, not missing a step, like a good baby boy. Yeah, step by step, right? And other is this competitive approach where time matters. You have to think, scanning, which can be ruled out, which cannot be true. So if I look at that, I'll only focus on a bracket to start with. Yes. Oh, that would take a longer time. Yeah, but you want. Oh, okay, that's fine.
See why that is true, right?
Because B minus C and C minus B.
Oh, okay.
B minus C and C minus B. And that's the
Yeah.
reason it's not true. Okay. Good. So I believe Ben. It will start with number 3, so have patience. You made it. Good job. Livia. Good job, Livia. Ben. Great job. Gabor number 4 and Emily number 5.
Oh man.
Almost. Let's see. If you haven't done Kahoot earlier, let's stop sharing and everything. Stop the sound at least. Now, how can I mute this? This is how I mute. Right. So if you haven't played Kahoot and you are doing it for the first time, good. It's a learning thing. I get good feedback about introducing Kahoot. So it's a very painful thing. You have to develop all the question and unique and time it all, but it's all right. I mean, if I get good output, why not? Yeah. Cool. Any question, concern from today's session? All good online?
I would have a question if it's possible. So for
Absolutely.
week
We
1,
got an hour
it
to answer
says.
your question. Sorry, Gabor?
So week 1 says we need to do the question from the textbook 1.1. Can I get a page number for the book? Which page number it's the questions are? Because my book gonna arrive 26, so 2 weeks from now, for some reason. And I can view online a few 27 pages or something like that. So I just need the pages for the questions.
Okay. Good part. I don't have the book right now. Okay, let me stop sharing first of all. Very good question. How would I find out? If I go into Moodle, let me see if I can find out for you. Okay.
Someone wrote page 13.
Oh, good job. Thank you.
Thank you.
Okay, that solves before I get into it. Good job. Okay, so you got that? Very true.
Yeah.
Any other thing I can help with?
I just have one question. Which
Please.
textbook is it exactly? Because I can't find on the Moodle which textbook it is.
Give me one sec. Give me one sec.
So,
yep, it's there on the PPT slide 1. I'll bring it on the screen and share it with you. Give me one sec, I'm just loading it. Let me share that screen again. Yeah, so this book, Essentials and
okay,
Examples.
yeah. All good.
On the website, it shows that it's the original edition. Is that the same as the second?
I
That's what
think
we have
you-
access to.
a second. Yes. Okay. So when you go into, I mean, there's a lot you can go through. Acknowledge and unit specification. See, teaching is, that's what is written as well here. Unit specific information. Yeah. Okay. Yes. Any other question?
Well, we have access to the original edition, and yeah, I'm just wondering if that's the same as the second. I know that there would be differences, but the website, our access is limited to the first edition. In the
Pearson website where you have
yeah,
purchased the book?
yeah, the ebook central, the ProQuest website.
I have no clue about it. Okay. Let me stop the recording because this doesn't need to be a part